Business Mathematics video class. I hope you are all good and safe. Last class we have learned some problems from the exercise 1.3 based on matrix inversion method. Last class we have learned how to solve the given equations by a matrix inversion method. Today we are going to learn a new topic, input-output analysis. It was invented by Professor Leontief. This method is a form of economic analysis between the economic sectors. This method is most commonly used for estimating the impact of positive or negative economic shocks and analyzing the ripple effects throughout an economy. The foundation of this method involves input-output tables. That tables contain a series of rows and columns. The industries are listed in the head of each rows and each column. Here our main aim is to determine the output level of each industries in order to meet a change in final demand based on knowledge of the current output of two industries. Suppose now I am going to take two industries A1 and A2. Here we are having two industries A1 and A2, where each produces only one type of product. Now I am going to assume each industries consumes some part of its own output and rest from the other industries for its operation. So they are independent. For example, here our industry A1 consumes some output of its own and rest from the A2. So A1 is dependent with A2, dependent of A2. Similarly, here our industry A2 consumes some output of its own and rest from the other industries A1. So here our industry A2 is dependent of industry A1. Here the two industries are dependent each other. Here I am going to take Aij and X1 and X2 as well as D1 and D2. Here our Aij be the rupee value of output of Ai consumed by Aj. Here our Aij be the rupee value of output of Ai consumed by Aj, where our I and J will be 1, 2, 3, etc. Then here our X1 and X2 be the rupee value of current outputs of A1 and A2 respectively. Here our X1 and X2 be the rupee value of the current outputs of A1 and A2 respectively. And D1 and D2 be the rupee value of final demands for the output of A1 and A2 respectively. Here we are going to use one result for finding the outputs. X equal to I minus B whole power minus 1 into D. Here in this exercise we are going to use this result for finding the output. Okay, here x equal to I minus b whole power minus 1 into d. No, here D is the demand matrix as well as B is the technology matrix, and our I is the unit matrix 1001 or 100010001. Here our technology matrix B will be like this: B11, B12, B21, B22, where our B11, here we need to find all the elements: B11, B12, B21, B22. Now B11 equal to A11 divided by X1, B12 equal to A12 divided by X2. Similarly, B21 equal to A21 divided by X1. Then B22 equal to A22 divided by X2. In general, Bij equal to Aij divided by Xj, where I and J will be 1, 2, 3, etc. Now, then our next topic, Hawkins-Simons condition. Here we are going to learn Hawkins-Simons conditions. Hawkins-Simons conditions ensure the viability of the system. If you want to test whether the system is viable or not, you can use the Hawkins-Simons conditions. If you want to test the system is viable or not, you can use this conditions. If the given system has satisfied the Hawkins-Simons conditions, we can conclude that the given system is viable. Okay, there are two conditions. The first one is the main diagonal elements. The main diagonal elements in I minus B must be constant. The second one, determinant I minus B must be positive. If you want to test the given system is viable or not, you can use this Hawkins-Simons condition. Okay, there are two. First one, main diagonal elements in I minus B must be positive. The second one, determinant I minus B must be positive. Okay, based on these two conditions, we can conclude whether the system is viable or not. Now we will do some problems on the exercise 1.4. Look at the book, page number 33. First problem. The technology matrix of an economic system of two industries is 0.50, 0.30, 0.41, 0.33. Test whether the system is viable as per Hawkins-Simon conditions. Here we are going to test whether the given system is viable or not by using the Hawkins-Simon condition. What's our given? Exercise 1.4. First problem. First we can write the given information. Here we are having one given information. What is that? The technology matrix has been given. The technology matrix has been given. So technology matrix will be denoted by capital B. Technology matrix capital B equal to 0.50, 0.30, 0.41, 0.33. Now I am going to find I minus B equal to I unit matrix 1 0 0 1 minus B technology matrix 0.50, 0.30, 0.41, 0.33. The next step would be, now I am going to subtract these two matrices. That is, I am going to subtract the corresponding elements. Now I am going to subtract these two. 1 minus 0.50, 0.50. 1 minus 0.50, 1.00, 0.50, 0.50. Then 0 minus 0.30, minus 0.30. Then 0 minus 0.41, minus 0.4. Then 1 minus 0.33. So it will be 0.67. We got our I minus B. See, look at our main diagonal. Here we have 0.50 as well as 0.67. They are positive. Here our first condition is satisfied. What's the first condition? The main leading diagonal elements in I minus B must be positive. Here our elements are positive numbers, so the first condition is satisfied. Now I am going to find the second one, that is determinant of this. Determinant I minus B equal to determinant I minus B equal to determinant I minus B 0.50 minus 0.30, then minus 0.41, 0.67. Now this is equal. Now I am going to expand these 2 by 2 determinant. I already told you how to expand this. Okay. First I am going to multiply these two. 0.50 into 0.67. Okay. Now I am going to multiply these two. You can take the whole numbers. So it will be 0.335. 0.335 minus. Now I am going to multiply these two numbers. Minus into minus plus. Minus into minus plus. Now I am going to multiply these two numbers. 0. You can take the numbers if you want to use the calculator, you can use the calculator for finding this and all. You can use the calculator in your public exam also. Okay, you can use the calculator. Okay, if you want to use, you can make use of the calculator. Otherwise, you can do it yourself. Now, I'm going to multiply these two. Minus and minus plus. 4 1 into 3. 0.123. Now I'm going to subtract these two. 0.335, 0.123. Divided to 1, 2. Okay, our answer will be 0.212, which is greater than 0, which is positive. It's a greater than 0. So, since the main diagonal elements in I minus B are positive and determinant I minus B is also positive. So here our Hawkins-Feynman conditions is satisfied. So we can conclude that the given system is viable. Okay. Now the second one. Similarly, we are going to do the second also. Look at your book. The technology matrix of an economic system of two industries is 0.6, 0.9, 0.20, 0.80. Test whether the system is viable as per Hawkins-Feynman condition. Here also we are going to do the same thing. First we are going to write B technology matrix as well as we are going to find I minus B, and then we can find determine I minus B. From the result we can conclude the solution. Surely there will be 1, 2 marks or 3 marks from the exercise 1.4. So you should listen the class carefully. You should do the examples as a homework. Problem number 2. First we can write the given technology matrix B. Technology matrix will be denoted by B. So we can write that technology matrix. Now I'm going to find I minus B. What's our I unit matrix? 1 0 0 1 1 0 0 1 minus. Here we are having minus, so I'm going to put minus. Then B. What's our B? 0.6, 0.9, 0.20, 0.8. Now I'm going to subtract these two. That is, we are going 0.4 minus 0.9 minus 0.20, then 1 minus this 0.2. Here look at our main diagonal elements. Here the main diagonal elements are positive. First Hawkins-Simon condition is satisfied. Now, I am going to find determinant I minus b. This is equal to determinant 0.4 minus 0.9 minus 0.20 0.20. Now this is equal to, now I am going to expand this 2 by 2 determinant. This is equal to, if we multiply these two, we will get 4 into 20. Get 0.08 minus, if you multiply these two, you will get 0.180. Now I am going to subtract these two. 0.180. So we can subtract from this. Minus 0.1. This is minus 0.1, which is less than 0. So our second condition is not satisfied. So here we can conclude that the given system is not viable. Okay, look at the third. Now we are going to do the third one. Look at the third one. The technology matrix of an economic system of two industries is 0.50, 0.25, 0.40, 0.67. Test whether the system is viable as per Hawkins-Simon conditions. Here also we are going to do the same thing. We are going to do check whether the system is viable or not. First we can write the given information. What's our given technology matrix? B is 0.50, 0.25, 0.40, 0.67. 0.67. Now I'm going to find I minus B. What's our unit matrix? 1, 0, 0, 1 minus B. What's our B? 0.50, 0.25, 0.40, 0.67. Now I'm going to subtract the corresponding elements. 1 minus 0.50 is 0.50. 0 minus 0.25 minus 0.25. 0 minus 0.40 minus 0.40. 1 minus 0.6. 7. 1 0.67. Our required answer is 0.3. See, look at our main diagonal elements. Here our main diagonals are passing. So our first condition is satisfied. Here our main diagonal 0.50, 0.33, they are positive. So our first condition is satisfied. Now I am going to find the determinant. Determinant I minus b. This is equal to determinant I minus b equal to determinant 0.50 minus 0.25 minus 0.40 0.33. Now I am going to expand these 2 by 2 determinant. I already told you how to find it. First I am going to multiply these two. It will be 0.165. Now minus and minus plus. Minus 0.1. Now you can take 0, 0, 0. You can put 1, 0 here. So if you subtract these two, you get, what will you get? 0.1650, 0.1056, 0.0. So our answer is 0.065, which is greater than 0. So our second condition is also satisfied. Okay, here we can write since the main diagonal elements in I minus b are positive and determinant I minus b is also positive. So therefore Hawkins-Simon condition is satisfied. So we can conclude that the given system is viable.